And welcome to problem number 8 in the 1.3 topic questions. I've already started laying it out. We've got a car starting from rest. We're told that it reaches a speed v in a distance d by accelerating at a constant rate a. Car B is going to do the same thing. The only difference is it's going to accelerate at 3 times a, which means when I'm finishing the drawing, try to think while you're drawing, right? So I'm going, well, this thing's going to be going 3 times that speed. Even though it doesn't really matter when I draw this out, the purpose of a drawing is to help you think things through. So as I'm drawing this out, I'm going, would I draw the car over here or over here? Actually, I draw it over here, right? Because it reaches the same speed, v, but it does it by accelerating faster. So you would be applying or exercising your conceptual knowledge of acceleration if you just draw the picture so that this thing gets to v in a shorter distance. Why? Because it's accelerating faster. And I'm going to call this distance db. Multiple choice question says, how far does it travel? You look at the choices and you realize if I call this db, that's what I'm trying to find. But in terms of d, right? Because the choices are there. And by the way, in FRQs, the prompts will actually say find something in terms of, and they'll list a whole bunch of letters or symbols. So getting used to thinking, actually articulating what you're trying to find and always saying in terms of by scanning the multiple choice questions, and you're going, oh, they seem to be all in terms of. Get used to that. It'll help your brain see the math expressions that match this, what you're trying to find. Okay, so we've got this going on. I want to find a distance db that in terms of that. Hey, timeless equations, right? So there's no time information. So if there's no time, why not start with this right away and see if it will suffice? There's the general equation. I'm just going to apply that to both, because by doing that, I'll have expressions with d and db in it. I'll take into account the 0 initial velocities, and we'll see what pops out. So here's A. If I write this equation for car A, substituting in 0 for my initial velocity, I get v squared has to equal 0 plus 2 times the acceleration times the displacement d. For car B, I have v squared, same v. That's got to be 0 plus 2 times my acceleration, which is 3a. And what's my displacement? db. Aha. So now I have 2 equations that take into account initial conditions, or what I know about the system, 0, 0, 3a, and I've massaged this, or I've expressed it in a form that gets me closer to what I'm trying to find, my d's and db's. So that's good, and hopefully you're probably seeing this and going, oh, I think we're done. Yeah, we are kind of done, right? Because these are both v squared, so I just set them equal to each other. 2ad has to equal 2 times 3a times db. db equals home free. You can do this. All right. I like number 8. Wish they were all that way. See you in class.